Before we start, I would like to acknowledge the traditional owners of the land on which we are all meeting today. For myself in Townsville and for others in Townsville, it's the Woolgoolakabba and Bindals people, and I pay my respects to elders past, present and emerging. My name is Rae Thomas. I'm the Research Academic Lead for the Tropical Australian Academic Health Centre. Welcome to the talk about p-values and confidence intervals. The caveat right now, up front, if you think I'm going to tell you today how to do tests that give you p-values and confidence intervals, you are at the wrong seminar. I am not a statistician. I'm not going to talk about statistics. I'm going to say things today that would make a true statistician cringe. And not because I'm wrong, it's because I'm going to really simplify things. So what I want you to learn from out of today is I want to talk to you about how to read the results of a study that compares two groups. So I want you to be able to read that by 2 p.m. And so when you see something like this, here's a modified abstract. It's a real abstract, it's modified. And it says, between October 5, 2009 and May 10, 2011, we screened 1,606 people, of whom 490 were randomly assigned to usual care. That's N of 244, or tailored exercise N of 246. 438 of 490 participants, that's 89%, provided 12-month follow-up data. Improvements in overall hand function were 3.6 points in the usual care group and 7.9 points in the exercise group. The mean difference between the groups is 4.3 with a 95% confidence interval of 1.5 to 7.1, a p-value of 0.0028. What I want to do is by the end of today, I want you to understand those numbers. I want you to think about those numbers, and I want you to tell me whether or not any of that is statistically significant and how you might know. What I'm going to do, and it's going to be interactive, I promise. You have to talk to me. I can't do this all by myself. So what I'm going to do, I'm going to talk to you about types of data, right? There are different types of data, and here's where I'm going to be shocked by any statisticians who are listening. Please, God, I hope they're not. Let's pretend there are kind of 3 broad categories, right? There's going to be continuous data, where it's any value that can be along a continuum within a defined range, right? So let's think about your like-it scales of 0 to 10, or your pain scales of up to 100, or anything that is a continuous measure. And this is where the word continuous gets statisticians a bit nervous, but for this purpose, let's say that that's what it is. Then you've got what we're going to call dichotomous data, right? So that means when you have outcomes that really only have 2 possibilities, a yes or a no. You're dead or you're alive. You have a stroke or you don't have a stroke, right? They're called events data. So it's a dichotomous, it's only 2 options, a yes or a no. And then very simplistically, there are other kinds of data, right? And there might be things like ordinal data, where the outcome is one of several ordered categories. So if you think about cancer stages and stuff like that, you progress in an order. So that would be ordinal data. Then you might have categorical data, where the order is rather arbitrary. So I might have red-haired people over here, brown-haired people over here, blonde-haired people over here. So it's arbitrary and there's no order to it. It's just a category, right? And another type of data might be interval data, where it's measured on a scale, but where each value is placed at an equal distance and it differentiates between the values. So those differences are actually meaningful between the values. So if you think about Celsius, there's a real meaning between 90 degrees and 100 degrees, or 30 degrees and 35 degrees. So that is interval data. Now, today, we are only going to focus on continuous and dichotomous, because I want to give you some kind of very, very broad and very general ideas about how you can use that knowledge when you understand that, how you can use that to try and unpick the meaning behind some of the results that you've seen in abstracts and stuff like that. I want you to look for clues. All right. Okay, practice time. All right, so here I want you to tell me, all right, if I have pain that's measured on a scale, right? After what I've just said, what is it? Continuous or dichotomous? Somebody yell out at me.
Continuous.
Continuous. Thank you, Ken. It's continuous data, all right? Because it's measured on a scale. You can find it could be 0 to 10, 100, whatever you want to do. But it's a continuous data. Yep. Yes. Continuous or dichotomous? Carol, you've got your mic off. Dichotomous. Yep. Nailing it. Smoking abstinence.
Dichotomous.
Yep. Cool. Score on a hand function scale.
Continuous.
Continuous.
Yep. Age.
Continuous.
Continuous.
Totally. Cool. All right. You guys, got continuous and dichotomous data. Okay. So if you want to know whether or not there are differences between groups in an article, you kind of need to know about p-values and confidence intervals, right? And the reason that I want you to think about dichotomous and continuous data is because they give you clues about how the researchers have probably gone about doing their statistical analysis. Okay? So let's talk about p-values for a second, right? P-values are the probability that a result is purely due to chance, right? P is for probability. Statisticians estimate that the value of P will be somewhere between 1, totally sure that the difference is caused by chance alone, right? Or 0, totally sure that it's actually not because of chance, that something is happening with the data. And so when you get a p-value of less than 0.05, it means that the likelihood, the chance of that result being caused by chance is less than 5%, because 0.05 is 5%. So that means that you're 95% sure something's going on. You might not be able to tell what's going on, but if you've got a p-value that is less than 0.05 and you're looking at it from a 95% perspective, then you're 95% sure something is happening in that space. Now, p-values, if articles give you p-values, it's usually quite easy for you to tell if something's significant or not. So I'm not going to dwell on p-values because if they're given, it's not hard. You just have to figure out if they're less than 0.05. But articles are moving away from p-values. And the reason for that is that they're not very helpful. I mean, they actually might tell you something statistically significant, but they actually don't tell you about the range of values that you might see or how precise the measure is or accurate. It just gives you this, it's statistically significant. So a lot of the newer papers are actually asking authors to move away from p-values and to put in confidence intervals. And that's what this is really about. This talk is about how on earth do you see confidence intervals, and can you identify whether or not that confidence interval means that those two groups are different. So here's a confidence interval, right? So when we're comparing group differences with confidence intervals, the confidence interval describes how uncertain is the association between the effect of the intervention. How much uncertainty, I beg your pardon, is associated with the effect of an intervention. So the confidence interval provide a range of values where the true value possibly sits within, okay? Now, just like that 95% p-value I told you before, 0.05, what we usually see are 95% confidence intervals. And these are saying that if we do this test, whatever the test is, if we do this test lots and lots of times, we are 95% sure that the average intervention effect, the average difference between these two groups lies between the upper number that you see and the lower number that you see. And they are the confidence intervals. So one is the lower bound, a lower confidence interval, and an upper confidence interval. So even though you might see, let's pretend you might see a number 3.9, right? You might have a lower confidence interval of 0.01, and you might have a higher confidence interval of 15, right? So even though you were told I think I said 3.9, even though you were told 3.9, it could actually be somewhere between 0.01 and 15. And that's why confidence intervals are much more important, because you can see that, wow, that's a really big spread, right? And you can narrow the spread of the confidence intervals, and the tighter the spread, the better. And often you can do that by having a larger sample, right? Because oftentimes when we have small samples, our spread of our confidence interval is bigger. Now, right, when we're looking at confidence intervals and you want to have a look at whether or not you can figure out whether there is statistical significance in that difference, you want to look at two things. For differences between group where subtraction is involved, things like mean differences for continuous outcomes, and this is why I wanted you to know about continuous and dichotomous, and absolute risk reductions, okay, then the point of no difference is 0. If we're looking for group differences between groups based on division, for things like risk ratios and odds ratios and hazard ratios, anything with the word ratios in it, usually, not always, but usually, you are looking for a point of no difference that is called 1. All right, I'm going to show you this now. Now, let's say we've got 2 groups, okay? 12 people went to the dentist, right? Group number 1 had a local anaesthetic before they had their tooth pulled, and group number 2 didn't. They had licorice rubbed on their gums before their tooth was pulled. They were asked after their tooth was pulled about whether or not they had pain on a scale of 0 to 10, right? So these are 6 people per group, and these are their pain scores on a scale of 0 to 10, right? Now that is continuous data, like you told me before, 0 to 10. Okay, no worries, got that. Now, when we're looking for the point of no difference, when we're talking about continuous data mostly, you have to look at the means of the group, right? And so if I was looking at the mean of group 1, who had the local anaesthetic, the number is 24. Those numbers add up to 24, and there are 6 people in the group. So the mean is 24 divided by 6 is 4, right? If I'm looking at the second group, the mean is 24 divided by 6. Those numbers also, surprisingly, add up to 24. There are 6 people in the group, so the mean is again 4. Now, in a continuous thing, I'm looking for the differences of means between the 2 groups, right? And if there is no difference between the means, the point of difference becomes 0. 4 minus 4, because there's no difference, equals 0. Has everybody got that, or do I need to explain that again?
Makes sense, Rae.
Okay, well, let's try something trickier. All right, let's try differences between groups, the points of no difference when we are talking about dichotomous data. All right, so let's say what we've got are 20 people signed up for a trial for a new treatment for cardiovascular disease, right? 10 people got the new drug, 10 people got standard care, right? What happened in those groups is 2 people died who had the new drug, all right? And that's called an experimental event rate. So 2 out of 10 people died, right? So that equals 0.2, 20%, right? In the second group, 10 people did not get the new drug. They had standard care. But also 2 people died. Now this is called the control event rate, and it is now 2 out of 10, and it's 0.2. It's again 20%. What I'm trying to illustrate is the point of no difference. So when you're looking at ratios, if I wanted to know what the risk of dying in either one of those groups was, the risk ratio, I would look at the experimental event rate, right? That 2 over 10 is 0.2, the first group, experimental event rate, divided by the control event rate. And that is 0.2 divided by 0.2, and the answer is 1. Now, these are the 2 numbers that you should have firmly in your head, right? If you are looking at mean differences between groups, the point of no difference is 0. If you are looking at dichotomous data and your outcomes are ratios, it is really super likely, although not 100%, but super likely, what you're looking for the point of no difference is the number 1. And I'll walk you through that in a minute as well. Any questions on this one?
That one's good too.
All right, I'm going to test you then, right? Because I do. Here we go. Same slide, all right? We know it's continuous versus dichotomous. You've already told me that. So I've got pain measured on a 0 to 10 scale. If I'm looking at the difference between two groups on this, what is the point of no difference that I might be looking for?
0 for pain, the first one.
0. Yeah, I even did this. Right, 0. I know, right? I had to put down my hand. All right. If I'm looking for death and there's a point of no difference between two groups and it's a dichotomous outcome, and I am telling you I'm looking for the risk of death in a group, a risk ratio, what is the point of no difference that I would be looking for here in a confidence interval?
1.
1. Perfect. What about smoking abstinence? You told me this was dichotomous, yes or no? What am I looking for? 0
Same
or
again.
1? What was that, Bianca?
Same again.
1 again. Score on a hand function scale. What am I looking for?
0.
0. Age. What am I looking for?
0.
Perfect. All right. That's the kind of stuff that I'm looking for. And the reason that we're looking for these is that if we've got a p-value, like I said, it's easy, but you're not going to get p-values for very much longer. You're going to get confidence intervals, okay? So we need to know how to read those confidence intervals. And now we've got activities coming up where we're going to have a go at that, okay? The first one is going to be a p-value. Okay, so here's a table. It's from a study. The DOI is underneath it. It's just a modified table. I've tried to make it easier for you to read. It's about the assessment outcomes are there. The intervention mean is there and the standard deviation, and the control group mean is there and the standard deviation. And then at the very last column, you have a p-value. Now, I told you that if p-values were less than 0.05, it indicated that something was statistically significant. So first of all, I want you to tell me, and why you tell me, what is the clue that helps you decide this? Are these measures here, do they look like they're measured continuously or dichotomously?
Well, there's a mean, so continuous.
Yes, right? So that's a clue. Things like mean, the word mean difference, things like that are clues that tell you that this is very likely to be, in our simplified skills workshop, a continuous variable. Absolutely. Okay. So first of all, yep, it's continuous. All right. So that gives me some ideas about what I might be looking at if I had a confidence interval rather than p-value. But I've got p-values here, so it makes my life a little bit easier, but it doesn't give me much information. All right. But in a p-value, okay, what assessment outcome then is statistically significant according to the p-value? Which one? What assessment outcome?
Patient's participation.
And why do you say that, Carol?
Because it's less than 0.05.
Yep, less than 0.05, right? So that's going to tell you that that particular patient participation looks like it's statistically significant. Are there any other ones that are statistically significant according to the p-value?
No.
Nope, I don't think so either. None of the others are less than 0.05. Okay, so let's try something else. Okay, this is a modified table from a placebo-controlled trial of an antihypertensive drug. DOI is down the bottom. Okay, so again, I'm wanting to know if it's statistically significant, but this time there are no p-values. So we're going to have to figure it out. Okay, and this is where your zeros and your ones come into play. So the very first thing I want to know, right, is whether or not you think these data are continuous or dichotomous, and what are the clues that give it away?
I'd say dichotomous because the clues being it's reported as a percentage for each group, and you've got a ratio and the confidence interval.
Yep. Confidence intervals happen all the time. They can happen for continuous or dichotomous. That's not a clue. The word ratio is a massive clue. Absolutely. Anything that says ratio indicates that this is going to be a confidence interval where you're hunting for a particular number, and it's the dichotomous one that I talked to you about. Showing numbers with percentages, with proportions, can trick you up. That is not always how you would look for dichotomous stuff, because you might actually they might subtract the proportions, which means that they've tricked you, right? So the word ratio, big headline clue. That's the one that you want to look at. All right, so this is dichotomous. The clue is ratio. So what we've just learned, if there was no difference between the groups, what is that point of no difference for a ratio?
1.
1. Perfect. All right. So here it is, the confidence intervals for 3 things, right? The cardiovascular events, death from non-cardiovascular, and death from any cause, right? And the confidence intervals are on the last column, and they're in the brackets, all right? So let's walk through these, right? We have cardiovascular event, including death. The risk ratio is 0.78, right? The confidence interval around that. So the risk ratio is 0.78. We're going to call that the estimate, right? That's what they think. About 0.78. The confidence interval goes, yeah, but hang on, guys, right? I know you say 0.78, but actually, if we did this test lots and lots and lots of times, the real value could lie anywhere between 0.70 and 0.86. That's pretty tight. That's quite a nice, tight, precise confidence interval. But I want to know from you, if the point of no difference is 1, when you're looking at confidence intervals, what you have to do is make sure that that number 1 isn't a number that could be within that range, right? So your range is 0.70 up to 0.86. Does that include the number 1?
No.
No. Anybody else want to say something? I got 7 chats. I'm really bad at doing 2 things at once. Cool. All right. You're right. It doesn't include the number 1. Is there a confidence interval there that does include the number 1? And if it includes the number 1, it means it is not statistically significant. Can you find a confidence interval that includes within that range the number 1?
The second one.
Yeah. So it is not statistically significant, this drug, between the 2 groups about death from non-cardiovascular causes. But it is statistically significant for cardiovascular event, including death, and death from any other cause. Right? So that's how you read confidence intervals between this. I got another. Okay. Another modified abstract. Okay, it was a randomized controlled trial to examine the effect of early intervention versus usual care for toddlers with language delays. DOI is down the bottom. They have secondary and primary child outcomes are presented. So very first thing I want to know is it continuous or dichotomous data, and what are your clues?
There's a mean.
Yep, Bianca said there's a mean. Anything else? Any other words?
Standard deviation or mean difference?
Mean difference is what I'm looking for. Yeah. Yeah. So the word difference. Difference means subtraction, right? You know, we're going to make one group, we're going to subtract it from another, and that's the mean difference. Okay. So again, no p-value. We've got confidence intervals. Very last column. We are 95% sure that if we did this test a gazillion times, the true mean difference would lie between those numbers. Now, if it is continuous and if it is a mean difference, right, what is the point of no difference that we would be looking for?
0.
0. Perfect. Okay, Bianca's answering a lot. Everybody else caught up? Who's lost? It's okay. Yeah, if you're lost, it's okay. It's totally okay. Kate's okay. All right.
I'm good, Ray.
All right. Thank you. All right. Good to go. All right. So let's go to the last column here, 95% confidence intervals, right? Now I've got the first one, expressive language, goes from minus 4.5 to 5.3. And you told me, because it was a mean difference, I want to know if the number 0 is included within that confidence interval range.
It is.
Okay, it is. So what does that mean then?
That's not statistically significant.
It is not statistically significant. That's right. What about the next one? They're telling me that if I do this test a gazillion times, the true mean difference lies between 0.15 to 10.4.
No, 0 is not within that range.
It is not. It just squeaks it though, right? It is not within that range. So that one is statistically significant. Okay, so receptive language. Is there anything else there that you can see that you think would be statistically significant?
The MCDI,
Tell me why you think that one might be.
because it goes from minus something to 83.
So we're looking for the number 0. Is the number 0 included in that range?
Yeah.
Then it is not statistically significant.
Oh, yeah. Sorry.
Yeah, so you got good. You found the 0, but
Yeah.
when you find a
Yeah,
0
it's
or
not.
a 1 in
Yeah.
the range, it is not statistically
Okay.
significant. Cannon, you had your microphone off for a bit. You're right?
Yes, I'm good. Yeah.
Okay. So what else is there? What else do we think might be statistically significant?
We've got the NDW and then the bottom one, which I can't see now because I've got my microphone on. So those two rows, PPVT -4. Yeah.
Okay, so NDW goes from 2.5 to 20.4. So yeah, the number 0 isn't in that range. So therefore, that's statistically significant. The PPVT4 goes from 0.4 to 10.5. So yep, the number 0 is not in that range, just, right? So that is also statistically significant. So that's how you kind of use those things. All right, now let's show you in pictures. Let's do this with pictures, shall we? Same deal. All right. The horizontal line that's labeled null hypothesis, no effect, is in fact our line. And this, in this instance, in this picture, it can be either 0 or 1. Take your pick. It's the line of no difference, right? This is just a pictorial example. The little diamonds there are called point estimates, right? That's the number that came before the confidence interval, right? Before the brackets. That's the point estimate. And then the lines that you see spread out, okay, with little truncated ends, they're the confidence intervals, right? So you have this one here, number A goes all the way up to here. So that's the high confidence interval, the high estimate. And then it goes all the way down to here, which is the low estimate. All right. You can see that that's a wide spread. So that's a low precision study. It's got a lot of spread there. Well, this one here, that's a big spread, right? So that's much less precise. This guy and this guy are nice and tight confidence intervals. So they're good. They might mean that they had a lot of people in them, or it might be that they just got really good measures, or it's just a really super good thing that they're doing. All right. So the width of the confidence interval, the range that sits in it, is about precision. Right. So my questions here. Now, this is graphically represented. What I want to know is there are two studies here that are not statistically significant. Can you tell me which ones they are? A, B, C, or D? And can you tell me
C and D,
why? Yeah, it's C and D. Why, Kenneth?
because it overlaps with the null hypothesis. If you assume that the
Perfect.
null hypothesis,
Yep, it does. So graphically, that line 0 or 1, it crosses it. It includes it. So therefore, there are two studies that are statistically significant. Which ones are they?
A and B.
A and B. Yeah, the others. The others. This kind of picture you'll find if you're looking at systematic reviews, and if they include things like meta-analysis and forest plots in their systematic reviews, this is the kind of figure that you will see all the time. It'll be swift around, right? So instead of that line of null effect, that 0, the no effect line, instead of that being horizontal, on a forest plot, it's going to be vertical, right? And so what you do is those confidence intervals cross or not cross the forest plot. And at the end of a forest plot, there's a diamond that summarizes it. It's called the pooled estimate, right? There's a diamond. The middle of that diamond is the point estimate, and the pointy bits of those diamonds are the confidence intervals, right? Same thing, right? Just pictures versus words. Okay. We're doing well, 135. So that's it, right? I'm going to do a little bit more. The bottom line is this is the abstract that we saw at the front, right? Here are all these numbers. What I'm interested in is the last sentence. Improvements in overall hand function were 3.6 points in the usual care group and 7.9 points in the exercise group. Mean difference between groups was 4.3. 95% CIs are 1.5 to 7.1. P-value is 0.0028. What's going on here? Who wants to tell me?
Oh, I'll have a go. So
Go,
it
Carol.
it's continuous, a continuous data.
Why? Why do you say that?
Because they're reporting a p-value and
No.
they're and the mean.
Mean
The
helps you
mean
out.
is yeah.
The other word that helps you out is the word points.
Points. Okay, yeah.
P-values can happen any old shop, right? Doesn't matter. P-values are continuous and dichotomous agnostic. They don't care. So they happen anywhere. But yes, you're right. It's continuous. The example is points, and they use the word mean. Keep going. What else we have got happening here?
So the usual care group improved more than the overall in their hand function. Sorry, the exercise group more than the usual care, as in 3.6 versus 7.9. The mean difference was 4.3.
Do you see how they did that?
They were subtracting. So that's yeah.
So they just did
that's a clue.
7.9 minus 3.6.
Yeah.
Okay. All right. Yep. Keep going.
Which okay, all right. If we look at obviously
Round.
the p value says that it's statistically significant
Because why?
because it's less than 0.05.
Yeah. But let's pretend the p-value wasn't there. Tell me about the 95% confidence interval.
So after what we've all been discussing today, or you've been teaching us today, it's 1.5 to 7.1, and we're looking for the 0 to be within that range, and it's not.
No.
So therefore it means that the point of no difference is not within that range, so there has to be a statistical difference.
Nailed it.
Significant difference.
Statistically significant
Significant
difference. That is correct. That is correct. Thanks for people who are replying on chat. I'm sorry, I'm not good at managing chat and talking and clicking on things, but I see that. Now, is everybody understanding that, or do I need to recap something? Really happy to recap. I don't consider this easy at all. I think that this is a little bit tricky to wrap your head around, and I am simplifying things a lot because a statistician, like I said right up front, would shoot me. But that's how you read a paper. Who else wants me to backtrack over something?
I just had a question. What if you see both the p-value and the confidence interval? Should they, if one of them shows, like, can it be a circumstance where one would show significant, statistically significant, and the other one shows not?
No, I'd argue there's probably a typo there. If I was reviewing the paper, I can't think of a place where in the same result, a CI would have, would be insignificant and a p-value significant. They complement each other. They're supposed to do the same thing. But what they've shown you in this one is the confidence interval shows you what the spread of the scores would be, whereas the p-value doesn't. So they should not differ. I can't think of a possible differ.
Second, yeah.
Yeah. Okay.
Thank you.
No worries. So we have a bit of time. So I popped up my sleeve something else that I thought was really important for clinicians to think about, right? So now you know how to just read something and think about whether or not it's statistically significant. What it doesn't tell you in any way, shape, or form is whether or not it's clinically important, right? Now that is critical, right? So you can have something that's statistically significant. The numbers say, woo, yes, difference here. But as a clinician, it might be that it's really immaterial because the difference is so small that it doesn't actually matter. So once a trial has shown that the difference between study groups is statistically significant, that's unlikely to be attributable by chance. We need to decide whether the difference is clinically important. This is the concept of clinical significance or clinical importance, and it cannot be measured using statistics. And I can't do that here. You as clinicians need to know about your clinical importance, right? So if we were talking about hand function, a physiotherapist will need to know on that scale, what is the clinically important difference that we need to know? This is clinical specific, okay? Statistics won't tell you this. For example, right, what if a large study finds that a new drug lowered systolic blood pressure on average by 1 milligram per mercury? The results are statistically significant, 0.05. However, it's 1 milligram per mercury, and the results might not be considered clinically important or worthwhile because it's 1 milligram, right? So statistically, good to go. Clinically, would you change your whole practice for one? Okay, that's something that clinicians have to decide whether or not it's important. All right, and I'm going to show you a picture in a minute, and so this is preferencing the picture. And I kept forgetting to turn on my notes. All right. So what I'm interested in doing is looking at how do you interpret the clinical significance based on kind of confidence intervals. Okay. So here, I'm just going to read this out, and that's why I put it on the text, because it's important text, and I'm going to read it all. Confidence intervals, and it's written by a friend of mine, Tammy Coughlin, and she wrote this great book on evidence-based practice. Confidence intervals can help make decisions about the clinical significance of the study result. Now, when we're looking at pictures, when the entire confidence interval and the point estimate, so that number before the brackets and the numbers inside the brackets, are below the smallest clinical worthwhile effect, then the intervention is not likely to produce anything clinically meaningful. When the entire confidence interval and the point estimate is above the smallest clinical worthwhile effect, we know with some certainty that the intervention is likely to produce a clinically meaningful effect. But when the confidence interval spans the smallest worthwhile effect and the point estimate is above it, it's really hard to tell. It's a judgment call. We don't know. So let's have a look at what that picture might look like. All right. So here we go. Same kind of picture that we had before, but this time there's two horizontal lines. And the big line, the non-dotted line, is your point of no difference line. 0, 1, take your pick, doesn't matter, right? So that's your point of no difference line. But in this particular study, they decided that even though that number, the point of no difference line, is one line, their clinically important line is a whole other line altogether, okay? Now, remember that we need to think about not only statistical significance, but clinical important, right? So in this group here, A, B, C, and D, there is a study that says it is statistically significant, but it is not clinically important. Can you tell which one it is?
Is it C?
It is C. Tell me why it's C, KM.
Where did it type into? No way.
Sorry?
I was typing and the microphone went on, so whoopsies, but yes for C.
Yes for C. And do you know why?
Because it's above the null hypothesis. Well, it doesn't cross through the null hypothesis, and it's below the minimal clinical importance.
Exactly, right? So we know it's significant because it doesn't cross that solid line. But we know it's not clinically important because it doesn't reach the threshold of the dotted line, either by the point estimate, the box, the yellow box, or the confidence intervals. So then, therefore, which study shows one that is not statistically significant, but it could be clinically important? Anybody who hasn't said anything, do you want to have a go?
Is it B?
It is B. Tell me why, Courtney.
So it's not statistically significant because it doesn't cross the null hypothesis.
Because it does cross. It touches.
Oh, it does. Sorry, it does.
Yep.
But it's also mostly above the minimal clinical importance difference line.
Yeah, so that yellow box, that point estimate, the number outside the bracket, is higher than the minimally important difference. So this is one of those ones that Tammy said it's really hard to tell, but it might be the confidence intervals, the values that the point estimate really truly fall within actually are quite wide, and they aren't statistically significant, but they might be clinically important, right? And that's an unknown. Which is the study that shows a difference that is neither statistically significant, nor is it clinically important? It's got nothing.
D.
What was that, Amy?
Was it D?
Yes, it's D, right? Because the confidence intervals, those lines cross the solid line. The point estimate, the yellow blocks, is underneath the clinical important line, and the confidence interval crosses that one too. So it's got nothing. It's not statistically significant, nor is it clinically important. And the last question I have, process of elimination perhaps, which study shows a statistically and clinically important difference?
A.
Oh, nice work, A. Because it is well above the solid line, right? And the point estimate is above the dotted line of clinical importance, and the confidence intervals are pretty much okay. So that is both statistically and clinically important. Okay, so are there any questions? Because we have 13 minutes left, right? I have gone through this. This is how I would help non-statisticians read a paper, get ready to have a look at the results that might change your practice. And I would help them read a p-value and a confidence interval, but confidence intervals more importantly because they give you more information. Is there anything else that you need me to go over in the next couple of minutes, or are you happy, or what would you like to do?
All good here.
Oh, sorry. I was wondering if you could just go over B again for me. Just to, so it's not statistically significant, but it's clinically, potentially clinically important. So what would the outcome of that be? What would you do?
Judgment call. Yeah, I don't like it. I don't like it. So we're looking at B here. So you can see B here, it's touching the line, right? That's a line ball. It's probably just a squeak over it here. So it's hard to tell. So it's not statistically significant. The point estimate here is above the minimal clinically important difference. So so there's something going on there. It looks like it's okay. I would worry about whether or not it's okay, because I said this one was a maybe. This one was maybe, maybe not. I would worry because the confidence intervals here are so big.
Yeah.
Right? I would think, if I was having a look, I would probably think it was a very small study. Right? It has big confidence intervals. I would be unlikely, if I was a clinician and I read this one, I would be unlikely to change my practice based on this study. I might want to go and see if I could find a study that's bigger, or a systematic review that pools these kind of things to try and figure out whether or not it is a clinically important difference. It might be. It's just looks a bit funky to me.
Yeah, no, that's great. Thank you.
Anybody else got any other questions?
Right, I've got one.
Yep, go Vinay.
This 5% or 0.05, do you know where it comes from?
Oh God, it's such a controversy. That's the thing. Someone made it up once upon a time.
Which is what I think. They just sat around the table and made it up.
As is most of medicine, mate. Let's be clear. All those thresholds are just simply made up by people sitting around a table. Look, it was there is a backstory, and I don't remember the backstory well enough. But bottom line is that it is kind of arbitrary. It's something that's so well entrenched now as research that we all just simply do it. And that's part of the reason why we're moving away from p-values and more to confidence intervals, because they just give us more information. But you can't really do a study without using these numbers to develop a sample size, a calculation for your studies, or anything like that, which is not this talk. But it was essentially, it was made up. Someone thought it was a good plan. And someone thought, oh yeah, 5%, that sounds pretty good. But there is a backstory. I'll try and find it, because I think it was quite amusing, but something that you would expect. But again, if a statistician listens to this recording online, I might be killed. But it's made up.
Cool, thank you.
That
Anybody?
was really, really useful. I was just wondering, will we have access to either the video recording or the slides?
All the video recordings for all of our webinars are up on the TAAHC YouTube channel. So when you go to the TAAHC webpage and you hunt through to resources, research resources and stuff like that, it shows you the link to all the YouTube page, so you can have all of those. I don't usually put out slides, but they're all on the channel anyway. But I'm happy to have a conversation if you need to.
No, that's all good. The link to will be good to that and other resources. Yeah, thanks.
Yep, no worries. Email me if you have any other questions. I run groups. Part of the reason Bianca was answering lots of questions was because she was taught this. So it's good to keep going and understanding it more. So I run these groups twice a year that talk about demystifying research and understanding these things and looking at evidence-based practice principles. So if you're interested in joining, there'll be another one starting sometime in the year. Any other questions?
Thanks, Rae.
Thank you, guys. All right. Thanks for coming. See you next webinar.
Thank you.
Now, the statistician Rhonda Jones is going to give a talk on the 8th of November, I think. Again, that information is on our webpage. our website. I will share that information in the usual channels that you have there. And our November webinar is all about translating research into practice. So in last Wednesday of the month, same time, same channel, and you'll hear us talking about translating into practice. All right. See you later, guys.
Thanks, bye.
Thanks.